Hello everyone, myself Sooraj S, Senior Geologist, GSI Raipur. Purpose of creating this video is to explain to you how we can generate contour maps for GCM data automatically using ARC-GIS. Many of you might be preparing contour maps using the Surface software. There you first prepare the grid files of the data, then you prepare the contour maps using those grid files. Similar is the procedure in ARC-GIS. Now here, instead of the grid files, we prepare interpolated rasters using the kriging method, and these raster files will be used for preparing the contour maps. First of all, I will show you what is the toolbox here. This is known as the geochemical batch contouring. Here I have written 3 Python codes for this toolbox, and I made a Python script also. So what this script will do is that it will fetch this Python codes from the script folder. You can see the script folder. So when I will run this batch kriging script, what it will do is it will fetch the kriging.py code from this folder and then automatically generate raster files. And then the batch contouring script, what it will do is it will fetch the script contour.py and generate multiple contour maps. And this batch masking script also will do the same thing using a mask polygon, where you don't have any data, so those regions will be masked and contour files will be generated accordingly. So first what we will do is we will do this thing manually. We'll see how to do this manually. So first thing is we have to create a personal geodatabase by going into your working folder, right clicking, then new, take a personal geodatabase, and within the personal geodatabase you right click and go to new and create your feature class polygons. What here I have created is a boundary polygon, which is my topo sheet boundary. Then I have a masking polygon where I have no data there. I have to mask those areas with this masking polygon, and I also have the data with all these composite sample data log and elements. So here I am only taking no, I will just remove this one. I don't need this one now. Now I will show you how to clean your data first from the Excel file. So here I am having this Excel file known as test data. Now I already had some columns with data here. You can see so many empty columns are here. So what I did was I deleted many of the columns to keep only these 4 columns. So you can't work with this type of Excel sheet, because what this will do is this will create some additional columns while you create the feature class from this Excel file. That additional columns will be filled with null values, and those values, those type of feature class, we will not be able to run the batch contouring scripts. So what we have to do is you have to select the whatever data we need to generate contours, and you will paste in another sheet. So here we will not there will be no problem while generating the feature class. I will show you with that one also. Here we had some sheet with empty columns, lot of empty columns. So this one is that is sheet 1. Now if I create this point feature class from this sheet 1, and I will save it as, I have to save it as a feature class, not a shapefile. Feature class within this, let me save it as data. Okay, now if you see this data, you see lot of additional columns with null values. So these are not ideal. So what I will do is I will just remove this. Now if I export this sheet number 4, which I have cleaned it, and I will save this as my data. Now if you see this one, there are no null columns here. Similarly for the rows also, if anything you have added any additional rows, you have to take care of that. And one more thing is that your Excel file, if you see this one, there should be no spaces in the data headers. In the file names and the data headers, you should not give any spaces or special characters like underscore, backslash, etc. So if you have any sort of spaces or here, like some spaces, if you have some spaces, you can trim off that spaces by using this function, like trim function in Excel, equal to trim . So what this will do is, if suppose you say you have some spaces here also you have some spaces, okay, what this function will do, trim function, what this will do is trim those spaces. Means you can see now, copy values and you delete this one. Now you see there are no spaces here. Now if you have any spaces in this one, what is the problem is that when we convert this to a feature class, those spaces will be converted to special characters, and that will be added here. So while running the batch scripts, this batch kriging and contouring, it will run through every data column. That time what will happen, this special characters will interfere with the scripts and it will not run. So we have to make sure there are no spaces in the data headers. Also you have no special characters or some character strings within, like ND, not determined. Some data sheets may not have some data for there, they will be writing like ND, or maybe there will be less than symbol. That also you have to replace. So you have to clean those things, and then only you have to create this Excel file. Then you have to export this to feature class. So after this, what we will do is create the raster files, interpolated raster files from this data. So that how we will do is we will go to ARC toolbox. Now before that one, we have to make sure whether the spatial analyst extension is present or not. To go to customize and extensions and see where your spatial analyst extension is enabled or not. Otherwise you enable it, and after that you go to spatial analyst, go to interpolation, then you have the kriging. This is similar to the kriging method in Surfer. So input your data. I have already in the table of contents here data, then you will create for SiO2, then I will save the raster files and there itself here wherever I need SI raster. Okay, then this will be a exponential semi-variogram model using the ordinary kriging method, and for this advanced parameters, lag size will be the default value. So the major range is nothing but the diagonal distance between the data points. means a larger distance, more than the diagonal distance. Now in this case it is 0.025, so I will put it as around 0.03, little larger than those distance. And I will set the nugget value as 0. Press OK. And I will set this as 100, and I have to set the processing extent, which is the boundary of the topo sheet. Layer boundary. And I press OK, and this will take some time. I don't need this one. This is my topo sheet boundary. So this kriging process will take some amount of time. So for multiple elements, it will take a much higher time to generate this raster files. But the contour files will be generated very quickly. Now you can see the kriging process is going on, and it will be completed. There will be a dialog box. Let me pause for a moment. Now you see the kriging file has been generated. This is the SI raster is here. Now this is only the raster file. Next step is to create the contour lines. For that you have to go to the spatial analysis, surfer tool, and contour. Select your SI raster, which is the raster file generated. Then output will be SI contour. Okay, save. Contour interval will be 1, something like 1. I will give, just press OK. And here you can see contour is already generated. You see these are the contours. Now if you want to color your contours according to your mean, threshold, etc., you have to right click and go to symbology. And quantities, select your field, contour field. Okay, then you can make it multiple classes, 6 classes, classify, manual. Now if your mean value is around 57, you can color accordingly. So you write 57 here. If you say your threshold is 63, something, I'll press it here, 64, 63, yeah, 63. Okay. Now you see you have 63 here. That will be your threshold value. So you color it different accordingly. So give you the same color for that. Or your mean value was around 56 or something. So I will color it differently. This one is above mean. Whatever color. So this one is below mean. So accordingly that will generate contours. This is between threshold and mean, and there are some values below mean. So accordingly you can generate your contours, and you can also label the contours. You go to the properties, then label field. Label field, you have to select the contours, make it as placement properties, you select it as on the line. Okay, then apply. Okay, then right label the features. You can see your contours are labeled. Okay, so this is how you manually generate contours, and this way you can save it as mxd file. You have to save it as mxd file, otherwise if you just remove this and take this again, this contour shape file again, this whatever symbology you have applied, means the watercolor you have given, that will automatically go away. So you have to save your mxd file, save it as mxd si, the file name as si, like that. Now for this I don't need this one. I will now just show how to automatically generate these raster files and contour files. And now to download this geochemical batch contouring toolbox, you can go into my GitHub repository, and the link will be given in the description box. This is my GitHub repository, and here you can go to here and download the zip files. So the zip files will be downloaded to your system. Then what you can do is extract that zip file and save the folder to any location wherever you need, and connect that folder location. And here you can see three scripts within the toolbar. So you can also, in some systems may not work because some proper path will not be specified, but on other systems it may work. If it is not working, you just right click, go to properties, and set the source of this Python code. Like go to the folder where you have the scripts. Okay, I have in the scripts folder, so I will select the appropriate Python code for the script. For contouring, it is contour.py. Similarly for kriging, it is kriging.py. For masking, it is mask.py. So you can set this here by going to the folder and setting the source of this script file. Then the first process is kriging. So what we will do here, we will krig the data which is present here in the table of contents. This is a batch kriging process, and it will take much time. So here only I have given only four data, so it will not take much time. Now next is to select the starting data column. This starting data column is the column from where your data is available, means elemental data is available. In my file you can see first column is the objective ID, second is the composite sample number, third is the latitude, longitude is the fourth one, and the data begins from the fifth column. So fifth column 5, 6, 7, 8. I only have 8 one, so you can give here starting column 5. This is my fifth column. Then what the script will do, it will automatically iterate through every field and calculate and generate the raster files. Output location, you can create any new folder here and name it as raster add. Then you select the extent. Extent means the boundary of your topo sheet, which I already have. Then search radius, ideally you can keep it as 100. That will do. Please don't input any decimal numbers here, then the script will not work. And press OK. Now it is estimating the semi-variogram and interpolating. So this is for the first element SiO2. Similarly for other 4 elements, it will carry out the interpolation and produce the rasters. The rasters will be saved here. If you see, there will be a raster folder which I have specified while running the script. That raster folder, all the raster files will be saved. So let me pause it for a moment. No, before that one, you also have to make sure your spatial analyst extension is present or not, and you have to clean your data in the Excel sheet itself. Then only this script will work. Let me pause it for a moment. And now you see the kriging process has completed. You can see the raster files. You press refresh once. You see, I had created a raster folder. You can see the rasters created from these datasets: SiO2, Al2O3, Fe2O3 and MnO. Correspondingly, you have these 4 datasets. Okay. Then the next step is doing the batch contouring process. First, you have done batch kriging and generated the raster files in the raster folder. Now next step is the batch contouring. So for this, the input folder will be the raster folder which we have already created. So go to the batch contouring, then the select folder containing the rasters. So what I have created, that folder I will select, raster, add, then the select data for contouring, that is the data which I already having data, and select the first data column, that is 5, 1, 2, 3, 4, 5, and give a contour tuning parameter, means it can be between 2 to 10 like that. So this tuning parameter, what it will do is generate appropriate number of contours. If you give a higher value, more number of contours will be generated. So for this purpose, I will put it as 2 and see what happens. Now you see contour have been generated. You can see this one. This is the Al2O3 contours. Okay, and remove that one. Fe2O3, SiO2 contours. You see here in MnO, these contours have not been generated because their contour tuning parameter we have specified that was not essential. That we have to specify a higher contour tuning parameter. So for some of the datasets, it may not generate the contours. So what we will do in this case, we will just move the already created contours to another folder. You have to move the contour files plus the raster files. Otherwise, when we will again generate the new contours, means generate the MnO contours, so this will again replace the already existing contours. Hence I have Al and the Fe raster also I will move here, and SiO2 also I have the raster and the contour. So this is final. I am just satisfied with the contour, so that's why I am just moving to another folder. This is the final contour shapefiles and the rasters. So if this raster is if we do not move the raster to the another folder, then what the contouring batch contouring script will do, that will again generate the same contour files in this raster folder itself. So we can just avoid that one. That's why we are moving this to another folder. Now again you can run this batch contouring, and you can select the folder containing the rasters, that is this one. Then data, this is the data. Charting column is 5. Now earlier we had given 2, now we can give 4, then it will generate contours accordingly. Now you can see you have already MNO contour was there, it got replaced with the new contour. See, you have generated an MNO contour. So whatever contour files we have generated, and if you are satisfied with that, you can move those contours to the other folder, move the contours and plus rasters, or you can leave the rasters there itself, no problem. So next will be the masking contour. Like for example, suppose if you don't have any data here in this composite cell and also in this composite cell, you want to mask those contours. Now actually the contour is like this, L23 contour will go through that area. We just want to cut off this contour from this area. So what we will do is that we will run the batch masking script. So here you have to select the input folder. Now the input folder, what is that? That is the contours, that the final contours what you have created. So go and select the contours file, add, then select mask polygon. This is the mask polygon which I already created to mask those contours. Here it is there in this one, mask, add, okay. Now the mask contours also will be generated here. Okay, the process has finished. Now you see, instead of dragging this one, I will drag this one now. Now you will just remove the mask. You see here. Now the contours have been masked in that portion. Okay, so this is how you run this script. Now one more thing what you have to keep in mind is that while running this script, please do not give any decimal values here in this field or in this field, because that will not run the script in batch contouring and also in kriging. Do not give any decimal values in both these two rows. And apart from that, if you see these contours and if you label those contours, we'll go into properties. If you label these contours, you see that you have a decimal place, means up to 5 decimal places. If you don't need that one, then what you have to do is go to the open attribute table, then select the column, then select field calculator and make it as Python. So what you have to do is you have to round this to any number of decimal places, 1 decimal place. So if you don't want decimal places, then you can take a round of contour, comma. If you don't need decimal places, you can put it as 0. If you need 1 decimal places, then you can take it as 1. I will put it as 0. I don't need any decimal places in the labels. I press OK. Now it has converted the decimals to the whole number. Now again, if I label features, now you can see there are no decimal places. So this thing also you can keep in mind. And now some points what you have to remember is that we have to first of all see whether the spatial analyst extension is enabled or not. Okay, then next is the you have to see whether any special character or spaces are there within the data headers. Also within the data also we have to check whether any characters or spaces are there, and then you have to input a whole number only, not any decimal values anywhere in this field, in the contour parameter field or the data column field, or in the batch kriging also. If you see here also you should not give any decimal values. And the select search radius, there you should give an ideal number of 100 because more the value, the more the processing time. So an ideal value of 100 is recommended. And next is that the contours what you have generated, the final contours, if you see that the number of contours which you have generated is sufficient, then you can move those contours to another folder. Otherwise it will be replaced while we are again running the batch contouring tool for with another contour tuning parameter. That time this will get replaced. So whatever contours what you feel it is okay, that you can move to another folder along with their raster files. And now there is another way to add this geochemical batch contouring toolbar apart from connecting the ARC catalog window. You can also right click in the ARC toolbox and click add toolbox and browse to the folder. This is my geochemical batch contouring folder, and select the toolbox and click open. Then it will get displayed in this ARC toolbox. It will take a little time. Here you can see that has already come in the ARC toolbox. From there you can operate the scripts. You can operate on both ways also, within the ARC catalog and also within the ARC toolbox. And other thing is that this works in the ARC-GIS version 10.3. I hope it also works in the higher versions. And when you download this zip file, this geochemical batch contouring zip file from this my GitHub repository, you will also get a readme file which I can show it here. Here you have the Word file where I have already mentioned how to operate the toolbox. And apart from this, this toolbox works only with the feature classes, not the shape files. Maybe in a newer version I can change the code for including shape files also. And other thing you have to notice that when you work with your elements, first you can work with a set of 20 elements or so. Otherwise you may be generating several raster files within the folder and it will be difficult to manage. Once final contour files are generated, then you can work with the next set of elements, and that will be ideal. That's all. I hope you like this video. Thank you.